So hello, everybody. My name is Solange Ramirez. I am a scientist working at the NASA Exoplanet Archive. And here I am to show you what is the functionality and the data that we have available for you to explore. The Exoplanet Archive has data on exoplanets, but also has additional data that supports exoplanet science. For example, we store light curves of transit surveys that include non-transits because people in the future may want to go back and see if any of these surveys detected the planets that they have, and hence have a larger baseline on the observations. So here we have our web page, the NASA Exoplanet Archive. And we have here several services. And first of all, on the top, you see the current counts on confirmed planets as of today, which is December 2014. We have 1780 confirmed planets in here. So this one we change every week as new discoveries come available for scientists. Of those planets, 459 are in multiple systems. Those are systems like our solar system, that they have more than one planet. We also have data on the Kepler candidates, which are discovered by the Kepler mission, which is one of the missions that we support. One of the things that we have is this functionality called Explore the Archive. And this functionality allows you to look for your favorite planet and see what is that we have on the archive. So I'm going to start showing you about that, and I'm going to start with a planet called GJ436b, because I know that is one of my favorite planets. So you basically type the name of the planet in this white box under Explore the Archive, and just click search. And this will start looking into our databases and collecting all the data, or at least an overview of all the data that we have. Oh, you need to have your pop-ups. So let me allow pop-ups for the Exoplanet Archive, and I do the search again. So the page that we are going to go will have some of and here it is. Here we'll have a summary first of what is that we have for that planet. So first of all, what is the name input over here that you put, and the positions on the sky, and now the number of objects within the search radius. It has one confirmed planet and two mass objects, and also have some associated literature data. And then we go down here, and it gives you some idea of what it is. So first of all, it is a planet, and of a orbital period of around 2.6 days, and a mass. And then we can go down here, scroll down, and see what other data we do have associated to it. Under the bottom here, we have links to other archives, like the IRSA data discovery page, which is also a service within IPAC, the Keck Observatory, and also MAST. Now, this is really a very high-level overview, and if you want to see details on this planet, you go into this other link here. As you see, the name that you enter is highlighted, and if you click in there, it will take you to the parameters overview. So for this parameter, we have 6 different sources of the planet parameters that are listed here, where it says planet orbital properties. One of the things that is very useful for our users is to really know where the data is coming from. Every single value in our archive is linked to its source. So, for example, in this panel here that is called Planet Orbital Properties, we have a series of planet parameter values, and here at the right-hand side, we have a reference. And all this are actually links to the NASA ADS service, which is the abstract service. And I click here, it will open another window with the link to the abstract service, where I can actually look at the paper in full. So we offer full traceability of the parameters within the archive. Now, if I scroll a little bit down, we have other planet parameters like masses and radius, as well as transit properties. We also provide links to other services like the Exoplanet Encyclopedia and the exoplanet.org services that are complementary to us in many ways. And at the bottom of this page, we have a summary of the stellar host star, like the positions and some brightness measurements, like in the B band and in the K band. What is the effective temperature of the star that hosts this planet, and others, luminosity, masses of the star, age of the star, and so forth. Now, this overview present by default only the planet parameters and a summary of the stellar information of the planet host. If we go to the left-hand side and we want to see more detailed information, we open these panels depending on the information we want to see in detail. For example, if I want to see more stellar properties of the planet host, I need to click on the square next to stellar property and then hit update and scroll down, and a new section will show up underneath the summary with the individual values for the stellar properties for the host star. And if you are interested, you can go and see other type of measurements like the stellar photometry that I'm going to do right now. I do update, and here shows all the stellar measurements in different bands associated to this star. One other feature that we provide is what we call this associated data. And the associated data is basically time series, spectra, and images associated to this object. So I'm going to click on the three of them to show you what type of data we can have for a particular object. And I hit update. So I go down and I get first into the literature time series. These are basically light curves, how the brightness of the star changes with time. And what we offer is to download this data. So I'm going to show you how the files look like. They look like this. They have a header, and then underneath they have the time and the magnitudes, which is a measurement of the brightness for the object. So this is the format that you get the data from. We do not offer at this point any way to visualize this data, but that is something that we are envisioning to do in the future. The other thing that we offer, like any of the other planet parameters, we offer the link again to the original reference for this data. So for this particular object, we have quite a bit of time series or light curves. We also have spectra associated, which come in a similar format as the time series. And we also offer like images. If people want to use this to go and observe, they can find the correct objects. So for that, for example, we have this finding chart where we do download, and we basically get the field of observation for this object, either with the Digital Sky Survey, the Sloan Survey, TUMAS, and WISE. So depending on which band the observer is going to observe this star, it can choose which frame to look for. Okay, so this is what I can show you for the confirmed planet. One other thing that I want to say on this page is that there are some rows that are highlighted, and these rows identify what we call the default set of parameters for this object, which are the ones that are going to show up in the table that that I'm going to demo next. We have chosen a set of default because people want to analyze and compare different planets to determine trends or any other physical properties. And for that, we need one set of parameters. Okay, so this is all that I had on this page. You can explore and add more information depending on what your interests are, but this is basically the place to go when you're looking for a single object. Now I'm going back to the home page, and I'm going to look for this table with data on all the confirmed planets, and there are several points of access for that. One of them is just clicking at the count here at the top left of the page, and that is what I'm doing right now, and that will bring a table, which is a flat table in an interactive environment where you can start filtering or analyzing in some way the data on the confirmed planets. So again, what we present at the first time is a default of columns of data that we have. So we have the name of the planet letter, the discovery method, the number of planets, the orbital period, semi-major axis. All these are associated quantities for the planet itself. But we also have other information on the left that are associated to the host star, like the position, the distance, the brightness on the B magnitude, what is the effective temperature of the host star, and so forth, and additional names here. If there is a quantity that you're looking for and it's not in here, you can see what else we have available, and you can go to this select column area and click in there, and you will see what are the defaults columns that are the ones that show up on the first time. Or you can go down and open up other sections of planet columns, and you have a wider set of parameters that you want to add. So to add them on, you just click on the box close to it if you want to add the equilibrium temperature, for example, of the planet, or the planet mass in Earth masses, not in Jupiter masses like we have it in the table. You do that. If you would like to see more stellar associated quantities like the parallaxes and the proper motions, or the spectral type. Let's do the spectral type, for example. We just click on there and set update selection. And these columns are going to show at the right hand side of the table. Here it is, the equilibrium temperature, the planet mass, the parallax, and the spectral type as we have selected. There are several things that you can do in this table to interact. For example, you can sort any of these columns by clicking on the arrows here on the left, to the top left of the cell in the label. So here I'm going to be sorting on the orbital period, because I wanted to see, what are the smallest orbital periods that we have, and that is the result. The table can be scrolled up and down here on the left if needed. Also, we can filter by adding a constraint in the white box under the label. So for example, if I'm now interested to see all the long period planets, I just need to put greater than 200, for example, to get all the planets that have orbital period greater than 200 days, and either click return or just wait a little bit. It will update by itself. So here they are, all the planets that are greater than 200. You can add multiple constraints in here. Right now I'm going to remove the constraints, because what I want to show you is our plotting, because that is another way that you can really visualize what is the what are relationships between parameters. So what I'm going to do now is to remove the constraint, and with that I just clear the table where the window where I added the filter, and type return, and now I have back all my planets, and I'm going to access the plot functionality. So I go here to the top menu and hover over plot table, and then go down and click on plot table. So a new window, it's going to appear, and here I have a plot of the planet mass by the planet radius, which is something that astronomers use to identify trends, and this is actually an interesting plot. Already here we can see that there are like two groups of planets already, one that it is a very low radius and the other one that is a higher radius, and most of them have different ranges of masses. If I want to zoom and look into this portion of the plate, I just use my mouse and I click and open up here, and this will automatically zoom on my plot. If I want to return back, I go here under and reset the zoom as an auto scale. I can change the columns that I'm plotting. These two columns are chosen by default, but if I want to see now what is the orbital period in comparison with the planet radius, I can actually choose the orbital period there and hit redraw, and now I have a different plot. And here I have this is actually a real data point of a very long period planet, but I want to zoom in here. I use my mouse to do that and see what is that I'm looking at in more detail. Now it seems here, like for example, even when I zoom, the stretch is not very good because the range in the orbital periods is actually huge. So one way that I can visualize that better is by using a log scale. So I go into the and the manipulation, different manipulations that I can do on the plot. So I click on the axis, and for the y-axis, I use a log scale, and I do redraw. And oh, sorry, I should have done the other one. Sorry, it's the X scale. That one to do log, and I hit redraw. And here I have a much better sense on how the distribution is, because I don't have all the low period planets in one small spot in my plot. So those are things that I can do to work with this manipulation. Another thing that we can do is, if I do in the line, I can change the line style, different colors, and also I can add uncertainties to my plots when in the tab called errors. I go back to the data, and what I want to show you now is that there are two things that, if you are happy with the plot that you have made, you can actually download your plot here in this icon. It will generate a PNG plot for you, or you can download the data that you have plotted, because we have filtered here for an area that we wanted, and that is the sources that we want to work with, and we can actually download the data. And this data can be actually saved in several formats, including the comma separated format that then you can embed in Excel and work with it later. Okay, the other functionality, the other plotting functionality is the making of the histograms. And for that, I go to the tab called histograms, and that one will generate a histogram for me. By default is the planet radius. But again, similar to the other plot, you can change the planet radius into the planet mass, for example, and it will get you another plot. Similarly, we can use different binning and scaling, and that also includes log scale, if that is what we want. And for this for this parameter, actually the log scale histogram looks much better. The same type of options that you have to download the figure and use it and save it and so forth. Okay, so that is basically what I had in this area. We started with a table of confirmed planets, and then we went into the plotter. Now there are, if you are not, if the function, the very basic functionality that we provide in here, it's not enough, and you will like to use other tools that you are more comfortable with, you can actually download this data. And to do that, you go into this tab here called download, and you first select the format. And if you are interested on working on Excel, for example, if you if you select the comma separated format, you can actually upload that file directly into Excel, and it will work. And you have other download options, like if you want to download all the columns or only the columns that you have selected, you can do that. If you want to download all the rows or only the rows that you have filter on, or the ones that you have checked here on these boxes, you can also do that. And then click here, download, and you will get your data. Actually, here in this Mac, it will open directly into Excel if you type here, okay. But at this time, I'm going to cancel. Okay, so this is what we have on the confirmed planets. So this is a live table, in the sense that every week or every other week, depending on the traffic on the literature, more planets are being discovered. And we make an effort to keep up to date on what it is in the literature, and for that reason we update our database once a week, at least once a week, when we have new planets in the astronomical literature. But the confirmed planets is not the only data set that we have available. If you go here to the home page, you can see that there are much more data that we have. One set of data that it's been very used by our astronomical community is the list of the Kepler candidates. So these are transit events that have been tagged by the Kepler mission as maybe being potential planets causing these transits. We keep track of all that activity in this Kepler candidate pages. So if I click here on the top, it will take me to a table which is very similar to the confirmed planet table. It uses the same underlying software, but this is only for the Kepler candidate list. And as you see, is the same. You have the same ability to interact with the columns, the same ability to download the data, and the same plotting routine associated to them. Now, this is a larger number of objects because not all of them has been validated and confirmed as planet, and this is also something that changes time to time when new work is being done by astronomers. Now, if I go back home and I'm going to try to explain a little bit more of what we have here accessible, in case you are interested on working, for example, on more basic data. In this area of our homepage, we have available different transit surveys. Our main mission that we support at this moment is the Kepler mission, and for them we have light curves, and we have Kepler objects of interest, which is the same as the Kepler candidates. We also have available searching on the stellar data on all the targets that being observed by Kepler. We have a table that tracks all the confirmed planets and all the different names that people use for the Kepler confirmed planets. And also we have here some documentation that you can read if you are more interested on going deep into these data sets. Other missions that are also transit surveys is the Corot mission, and for them we also have data associated. We have data from the Super WASP transit surveys, and this is a large data set. It's about 18 million light curves. And also we have other minor surveys that some of them are ongoing and some of them are finalized at the moment, but you can go there and look and see in all these links of what is that we have for them. The other set of data that we have is it's not data, but more services and tools. It is on the bottom left here, and For that, we have a periodogram tool. We have the periodogram basically takes a light curve and determine if there is any periodic signal in the curve, and it tells you what the period is and the amplitude. The transit and ephemeris service basically predicts when the next transit of an object is going to occur, a transiting object. We also have our bulk download service is when you are interested in downloading a whole set and you don't want to do it one by one. We provide pre-packaged sets of data. The API, which is the build a query tool, it's more intended for people who would like to code a direct access to our service, and the API is an interface that will basically connect directly to the code. So if you are interested in coding, that is where you can actually look for more information. Here on this other panel that it says work with data, it's basically direct links to other types of data sets that we have in-house, and also a direct link to our plot routine, our plot functionality here. Now, to finalize, what I wanted to say to you is we do have also plots that are generated and that they are ready to use for visualizing a set of data. So if you are not comfortable with going into our own plot software, you can click here on plots and scroll at the bottom, and you can have direct visualization of some common plots that astronomers do in order to understand what set of data is. And you're welcome to download this and use them in your classrooms or showing to your students and so forth. You can, if you click on any of them, it will get you a larger resolution. So for example, here I have the mass period distribution for all the confirmed planets, and color coded with different techniques that they have been used to discover these planets, and you can really see some interesting trends. Like, for example, the radial velocity technique is more sensitive to long period, high mass planets, while the transits is more sensitive to lower period, but it includes a large range on masses. Other techniques are much more scattered, like the imaging. The imaging, it's only sensitive to much longer high mass end of the planets, while the microlensing, it's all concentrated in this area, also for long period planets, but a wider range on masses. Okay, that is basically what I had to show you, and thank you so much, and I hope you enjoy it.